All right, this is chapter 5, section 4, and it's going to be the sum and difference identities for sine, and we also throw in the tangent sum and difference identities for tangent as well. And if you got the third section, the sum and difference identities for cosine, when you watch this section, you're going to see it's the same thing. It's analogous. And so you start hitting the fast forward button through this video. That's okay. Make sure you can do the problems, and make sure you understand them, and make sure you're getting the answers correct. So maybe fast forward to the answers. But if you've got it in 5.3, you're going to get it in 5.4. If you didn't get it in 5.3, then watch this carefully, because here's your second chance to get this material, because it's very, very similar to 5.3. Okay, so start with sine of a plus b. Do you think that equals the sine of a plus the sine of b? Do you think that's going to work? We did that already with cosine. We asked that question, and hopefully you remember the answer. And maybe, we do an example, the sine of 90. You look in your chart. The sine of 90 is 1. The sine of 45 is the square root of 2 over 2. The sine of 45 is the square root of 2 over 2. If you add up the square root of 2 over 2 and the square root of 2 over 2, you get 2 square roots of 2 over 2, or square root of 2. So is 1 the same thing as the square root of 2? And no big surprise if you remember 5.3. The answer is no. You can't just add up the trig functions. So the sine of 10 and the sine of 20, they don't add up to the sine of 30. So instead you need these identities. And again, we're not really focused on the derivation here. We're going to focus on the application. But you get this identity. The sine of a plus b is sine a cosine b. And now note, unlike the cosine, when this is a plus, this is a plus. And then it goes cosine a sine b. So it kind of gets them switched around a little bit, but it's very, very similar to the cosine addition formula. And sine a minus sine b, sine cosine minus cosine sine. So we've got those identities that we're going to work with today. Like I said, analogous to 5.3. Okay, why would you use these? Well, before calculators, you could use them to find exact values that weren't in your chart. So 30, 45, and 60 were in your chart. But other values, 15, 75, 105, you could use these identities to find those values. You'll still use these today in calculus. When you find the derivative, or actually when you find the derivative using the definition, these will come up. And again, your professor will be so impressed when he asks, who remembers the sine addition identity or the cosine addition identity? And your hand goes up. That professor will be so impressed with you. Okay. You know there's 6 trig functions, and there's kind of our 3 primary ones, sine, cosine, and tangent. And so tangents are not left out. There's also tangent addition and subtraction identities. Those we could derive somewhat easily, because tangent, remember, is just sine over cosine. And so we've got our addition identity for sine. We've got it for cosine. And so from that, and then rationalizing the numerator, not rationalizing the numerator, but simplifying the bottom of the fraction, we could easily get these 2 identities as well. So these will be identities, the 2 tangent ones, the 2 sine ones, in addition to the 2 from the previous section that you just need to know off the top of your head. Okay, let's try this. Let's try the sine of 105. And again, you immediately think of your chart. And we'll write this one more time. And after that, I'm going to assume that you just have this memorized. In class today, you guys already had it memorized. So you may not even need to write it out. So we've got our key angles. These are in degrees. Sine, remember, is an increasing function. Cosine is a decreasing function. So we get these values. And tangent is the quotient, so I get a 0, get an undefined, I get a 1. Here's the square root of 3 over 3, and here's the square root of 3. Okay, so that you will know off the top of your head. Sine of 105. Well, 105 degrees, I look over here. How do I get 105 degrees? How about a 45 and a 60? So I'm going to write this as the sine of 45 plus the sine of 60. Well, can't that equal just the sine of 45 plus the sine of 60? No, that's the point we made on the previous page. That's why we learn these identities. And so the sine identity, you can look back on the first page to check it. It's going to be the sine of 45 cosine of 60 plus cosine of 45 sine of 60. And like I say, if you understood section 3, this is going to go very quick and easily for you. Look them up. Sine of 45, root 2 over 2, Cosine of 60 is 1/2. Cosine of 45, root 2 over 2. Sine of 60, root 3 over 2. You know how to handle square roots. So it's the square root of 6 here over square root of 4. Square root of 2, square root of 6, those are not like terms. So the best I can say is square root of 2 plus square root of 6 all over 4. So even our answers look like the answers from lesson 5.3. But that's the idea for these problems. Okay, let's look at some variations here. Here's a nice one, it's a tangent. And so we go back to our tangent identities. And I know I'm going to need to use the addition one because how do I get 105? That was 45 plus 60. And so I see on the top when it's plus, on the top there's a plus, and the bottom there's a minus. Okay, so let's see if we remember that. So we got a plus on the top and a minus on the bottom. So a tangent of 105 will be, and again 105, let's just write this out in a couple steps here, will be 45 plus 60. So using my identity, that'll be the tangent of 45 plus the tangent of 60 all over 1 minus the tangent of 45 tangent of 60. And if you want, take a sneak peek back and make sure that is correct. Let's just look one more time and look at that. Tangent of 45 plus tangent of 60, 1 minus tangent of 45, tangent of 60. Okay? Know these values? Tangent of 45, 1. Tangent of 60, square root of 3, 1 minus 1 times square root of 3. So on the top of our fraction, we've got 1 plus square root of 3. At the bottom, we have 1 minus the square root of 3. And trig is valuable just by itself, it's valuable, but all the algebra we review is also valuable. And remember, you cannot leave a square root on the bottom of a fraction. When it's 1 minus square root of 3, how do you get rid of it? We multiply by the conjugate. So we take the top and bottom by 1 plus the square root of 3. So this alone is good practice. Okay? On the top of our fraction, we FOIL that out. First gives us 1. Outside gives us square root of 3. Inside gives us square root of 3. And look at the last. Square root of 3 times square root of 3 gives us just 3. All right, on the bottom, FOIL it out, I get 1. Outside gives me square root of 3. Inside gives me minus square root of 3. And last gives me minus 3. Simplifying on top, it looks like 4, because that's the 1 and the 3. We have 2 square root of 3. And on the bottom, the 2 square roots of 3 cancel out, and 1 minus 3 is negative 2. Now I can reduce my fraction by 2, and I get negative 2 minus the square root of 3. And if we think about that, we were in the second quadrant, a smart trig class. In the second quadrant, the sign is positive, so it shouldn't surprise us our answer is negative. It doesn't prove our answer, is negative 2 minus root 3, but at least we know it's the right sign. Okay, a couple more of these just to get the idea. Sine of negative 15. We dealt with that with cosine already. There's an identity with a negative in the sign, and we learned if I have the sine of a negative angle, it's the opposite of the sine of the angle. So if I was doing this problem, the sine of negative 15, I would use that identity and say, well, that's the opposite, of the sine of 15. And I would go through and do this whole problem with the sine of 15, get my answer, at the very end, bring in the negative sign. Okay, so let's do the sine of 15. A couple ways to get 15. 60 minus 45 or 45 minus 30. Doesn't really matter which way we do it. Let's go with 45 minus 30. I use my identity. It goes sine, cosine, goes minus, oops, hopefully you caught that mistake. That was cosine of 30. Minus cosine, sine. Work through that. Sine of 45 is square root of 2 over 2. cosine of 30 is square root of 3 over 2. 45 is cosine square root of 2 over 2. And sine of 30 is a half. And it looks like we get one of our common answers. Square root of 6 minus square root of 2 all over 4. And don't circle that answer yet, because remember, we have this negative out in front. Have to deal with that negative yet. And so I make everything negative. So my final answer for the sine of negative 15 will be the opposites. So I'm going to have negative square root of 6 plus square root of 2 all over 4. Or you might see that more commonly written as square root of 2 minus square root of 6 all over 4. Okay, you guys like radians? Hopefully you do. Here's pi 12ths. I don't think I deal with the radians too much. I would take out that radians just like we did with cosine and say pi radians is 180 degrees. So I've got 180 over 12. So it's a sine of 15. And I can immediately turn back to the previous slide because I just did the sine of 15. So if they gave me radians, I think I would avoid those radians and switch it to degrees since we're a little more comfortable with the degrees. All right, same thing here. Tangent of pi 12ths. That's the same as the tangent of 15. And now we've got two ways to get 15, and we can think about this a little bit. I'm going to recommend the tangent of 60 minus 45, just because the tangent of 60 is a square root of 3. And the tangent, if I had 45 minus 30, if I use that instead, the tangent of 30 is a square root of 3 over 3. So it brings in another fraction. So square root of 3 over 3, which I'd rather avoid. So I'm going to go with the tangent of 60 minus 45. And these identities aren't quite as easy to remember, so let's just refresh your memory. So tangent with a minus. So tangent of 60 minus 45. So we're going to subtract on the top and then do the opposite on the bottom. All right. Let's try this. So we got the tangent of 60 minus the tangent of 45 all over 1 plus tangent of 60 tangent of 45. And I think you can see this is going the same direction as our previous tangent problem. Tangent of 60, root 3. Tangent of 45 is 1. 1 plus root 3 times 1. So 1 plus square root of 3 on the bottom. So you get the square root of 3 minus 1 all over 1 plus square root of 3. You can't leave square roots on the bottom. Let's multiply by the conjugate. 1 minus the square root of 3. 1 minus the square root of 3. And let's see where that takes us. FOIL out on the top. I have this in a funny order, but we can live with it. First gives me square root of 3. Outside, root 3 and 3 is 3. Inside is minus 1. And last is plus square root of 3. On the bottom, first is 1. Outside is minus root 3. Inside is plus root 3. And last is minus 3. Combine our like terms. We can see a negative 4 on the top and a 2 root 3 on the bottom. Goodbye to the root 3's. We get a negative 2. Divide that in there. Find some open space over here. And it looks like a 2 minus square root of 3. And again, 15 degrees is in the first quadrant. 2 is bigger than square root of 3, so it makes sense that we get a positive answer for that. And I think this is a good spot to stop with these problems. You can look at some of the other ones and say, oh, these look just like the cosine problems. They do. We're going to take this over 2 days so we can pick up some of the other parts of this on the next day. But this certainly gives you a good feel for the sine identities and the tangent identities. And again, we have these problems coming up, and then some of these trickier ones coming up as well. But you've seen all these tricks with cosine, so it'll look very similar with sine. So that completes our lesson.